Hello, this is Discrete Maths 1081 and I'm going to look at some of the problems in Chapter 3. Now in this particular chapter, rather than simply solve the various selection of problems, I want to actually say a little bit more about some of the mathematics behind some of the problems as well, and just give a few little bits of, I hope, interesting comment. The first one I'm going to do is proving an inequality about some numbers, so it's a very specific inequality. There's no x's, no variables. We're proving that this number on the left is less than this number on the right. And so I'm in fact going to show you 5 proofs of this, 5 different approaches, 2 of which are not acceptable, 2 of which will be wrong, and I want you to see why there's problems with them. But I'm going to show you various different approaches to this. So here's my first attempt. So what do? I use a calculator. So I type this number into the calculator, and I say this one's less than that one, finish the problem. Well, in this course, that's not going to be counted as an acceptable proof. And in fact, mathematicians often argue about whether one is allowed to use computation, some computer program, or even a calculator as part of a mathematical proof. Well, despite what various arguments for and against that, in this course, this is going to be worth no marks. So we're not going to accept that as a legitimate proof in this course, because we don't know whether we've entered the number properly, we don't know what rounding there is. It may be that these 2 numbers are very close to each other, and it's very hard to tell from a calculator whether the result's true or not. So anyway, in this course, no marks. Righto, well, let me try a second attempt. So second attempt, and I start with the thing I'm trying to prove. So I've got 2 plus square root of 2 plus root 2, square root of 2 minus root 2 is less than 2 root 2. There it is, and I'm going to square both sides. So I square, everything's positive. I square both sides, square the first, square the second, times them together and double it. So when I take twice the product of these, the bits under the square root sign, I'm going to get 2 plus root 2 times 2 minus root 2, which is a difference of 2 squares. So it's that squared minus that squared. So that will give me 2 squared is 4 minus root 2 squared. So that happens there. On the other side, when I square this, I get the number 8. Righto, so now I cancel out the root 2's, do a bit of simplifying. So I get 4 plus 2 root 2 is less than 8. Subtract 4 from both sides. 2 root 2 is less than 4. Square both sides. So I'm going to square now. Square both sides. That'll give me 8 is less than 16. And that statement is true. Therefore, my claim is that the original statement is true. After all, I started with this, I fiddled around with it, I got down to something which I know to be true, and therefore I want to try and conclude that what I started with was true. Well, with a bit of thought, I hope you see there's a bit of a problem with that. There's a logical error in that. For example, I could start out with the incorrect statement 1 equals minus 1. I can square both sides, just like I did here, and I get 1 equals plus 1. And that's a true statement, but that one isn't. So you can't start out with something that you're trying to prove and then just get down to something true and then claim that's a valid proof. So this one also, this proof has serious logical problems with it, and this is worth no marks. So that's not a very good attempt either. So because the problem with it was I started out by assuming the very result that I was trying to prove. And so every line in this begs the question. It assumes that what I'm trying to prove is in fact true, and that's not a valid proof. Well, that's not going too well so far, so let me now try a third attempt. Now, although this second attempt was not very good and wouldn't get any marks, from it I can actually salvage a proof. So what I can do is I can take the steps of this and I can work backwards, checking that the steps are valid at each stage, and that will give me a valid proof. But as you'll see, not a very clear one. So third attempt, I'm going to start with the last line. 8 is less than 16, that is a true statement. And then I'm going to take these are positive, I'm going to take the positive square roots. So the square root of 8 is 2 root 2, square root of 16 is 4. And then remember, if I'm writing this, imagine you couldn't actually see this here. I'm writing this with my eye on the previous attempt, but suppose I couldn't actually see that there. In my next step of the proof, I magically add 4 to both sides, which over here is totally unmotivated without looking back over to here, but I magically add 4 to both sides. And now I have the brilliant idea of splitting up the 4 into 2. I'll take one of these root 2's, I'll split up the 4 into 2, and then I'm going to write this as minus root 2. So I'm going to break up the 4, I'm going to add and subtract root 2, and I've still got one of these left, so this is 2 root 2, and that's less than 8. And now again I make the amazing observation that this factor over here is in fact the square root of 2 plus root 2 plus the square root of 2 minus root 2 all squared. And that's less than 8, and you can check that's true by just expanding it back out, and yes, it all works. And finally I take the square root, take the positive square roots, and I end up with square root of 2 plus root 2 plus the square root of 2 minus root 2 is less than 2 root 2. Now that is a perfectly valid proof. I don't think I've made any mistakes there, so that one is worth full marks. It's correct. It's very obscure. If you picked up a book and saw this as the proof, you would wonder how on earth they got there. What motivated them to say 8 is less than 16? Well, it's true, but why would you suddenly write that down? What motivated them to split this up in this very clever way and then to observe it's a perfect square? Nothing's motivated. It's a correct proof, but it's a very obscure proof. So it's full marks, but very obscure. It's full marks, but it's very obscure. And you wouldn't know how to replicate it or how to generalise it or do anything interesting with it except to sit back and marvel at how clever it was to be able to write this down. Well, so it gets full marks, but it's very obscure proof. So it's not a very satisfying proof. So I want to try a fourth attempt, which also will be a valid proof, but I hope a little bit clearer. So here's my fourth attempt to get a valid proof, but a little bit more clearer and more obviously motivated than that proof there. So take the left-hand side and give it a name. So let x be the square root of 2 plus root 2 plus 2 minus root 2. And I want to try and show that this x is less than 2 root 2. Now, given what we've been doing, the obvious thing I'm going to do with x is to square both sides. So x squared, as we saw before, is 2 plus root 2 plus 2 minus root 2 plus twice the product in here gives me 4 minus 2, which is 2. Simplify this a little bit, I get 4 plus 2 root 2, as we saw before. Now you keep your eye on the goalpost. I'm trying to get to 2 root 2 squared, which is 8. So I want to toss something away here and try and get this less than 8, and I'm going to get rid of that square root sign. Because after all, the square root of 2 is less than 2. So just note that step there. I'm going to say the square root of 2 is less than 2. Having done that then, simplifying that, I get 8. So at this point, I have shown that, therefore, x squared is less than 8. And I should also note that x is positive. So taking positive square roots and noting that x is in fact positive, taking positive square roots, we have x then is less than 2 root 2. And that's what we had to show. So that proof also is worth full marks. I've said everything that needs to be said, and I've given a proof of it. And it's much more clear, it's much more straightforward. You start with this side, call it x, do some work and establish that x squared is less than 8, and there's the result. So that's my 4th attempt. And so far that's the best attempt. The first 2, well, they were worth nothing anyway. And my 3rd attempt, although correct, was very obscure. There are some times, though, you'll see in some of the discrete maths problems where this is sort of roughly what you do. If you can't see how to do it directly, then try writing the things down on a scrap piece of paper and then copy the steps in the correct order and then destroy the piece of paper you wrote on initially. I want to finish off by just showing you one more proof of this, which is at a higher level. I want to show you a higher level proof. A proof that's a little bit more abstract, a little bit more complicated, but enables us to see why this is true in the first place and how to generalise it. I mean, where did they get this formula from? Was it just invented? Where did it come from? So this is going to be my 5th attempt, which I wouldn't expect a student to do in a test, but it's just another interesting way of looking at this problem. And I'm going to do this using some simple idea from calculus. So I'm going to draw the graph of y equals the square root of x. So I'll call this function f of x is the square root of x. And what do we know about this function? Well, f of x is concave down, which you can see also if you take the first derivative of this will be 1 over 2 root x, and the second derivative will be negative. And so you see it's concave down. And I'm going to pick some interesting points on here, and the points I'm going to choose here, I'm going to choose the point 2, and I'm going to choose the point 2 minus root 2, and I'm going to choose the point 2 plus root 2. And I'm going to see where these are on the graph. So when I go up to the graph here, at this point, this is going to be root 2 because this is the square root of x. This height here is going to be the square root of 2 minus root 2. And this point up here is going to be 2 plus root 2, take the square root. And I'm going to join together these two using this idea of concavity. If I join these 2 points together here, I can see from the picture that the midpoint of these two is going to have its x coordinate will be the average of these two, and the average of those two is 2, so that will lie directly in a straight line there. And I can see that the y-coordinate of the midpoint, because by concavity, is going to be less than the y-coordinate on the curve. Less than the y-coordinate on the curve. So let me give these 2 points a name. So I'm going to call this point here A, this point here B. So by concavity, I'm going to put some English here. Concavity, the y value of the midpoint of AB is going to certainly be less than f of 2. So the y value here is going to be less than the value of 2. Well, now I'm finished because the y value of the midpoint is the average of the y coordinates. So that says you take root 2 plus root 2 minus root 2 divided by 2. And that's going to be less than the y value here, which is root 2. We should have that root 2 a little bit lower there, I think. That should line up a bit better with that one, just to make it clearer. So it's root 2, so that's the y. Sorry, I had it right the first time. Sorry, there it is there. So that's going to be less than root 2, and finally then multiplying by 2, I get root 2 plus root 2 plus root 2 minus root 2 is less than 2 root 2. And that proves the result also. But this one is more interesting proof because you see how you could generalize this in many different ways. I could put a 3 here, for example. And if I put a 3 here, I could go 3 minus root 2 or 3 plus root 2, or I could change the root 2's here, or I could change the curve to, say, the cube root of x, and I could get formulae for cube roots, and we see how it nicely generalizes. We see how it nicely generalizes to other cases. And so that's a much harder proof and a much harder application of it, but it shows us where the problem came from and how to generalize it.